So today we are going to discuss the numericals of part B. In this exercise we have to deal with two formula. That is when there will be temperature change, that is when something will be heated up, when I will supply heat energy and there will be rise in temperature. In that case you will use mc delta t, q equals to mc delta t. And when there will be state change, then you will use q equals to ml, where L will be the latent heat of fusion, latent heat of vaporization. Mainly here ice and water, this kind of sums are only given. So these two formulas will help you here. Okay, and you have to be careful whether, like, regarding the units, like mass is given in gram and the specific heat capacity is given in joule per kg. In that case you have to convert. Okay, so let's start with the numerical. 200 gram of ice at 0 degree Celsius converts into water at 0 degree Celsius in 1 minute when heat is supplied to it at a constant rate. So 200 gram of ice at 0 degree Celsius to water at 0 degree Celsius. So mass will remain constant. That is 200 gram of ice will be converted to 200 gram of ice at 0 degree centigrade will be converted to 200 gram of water at 0 degree centigrade. So ice to water, there will be state change, but there is no temperature change. So here we will use the formula Q equals to ml. So the formula used, that is Q equals to ml. So mass given, specific heat capacity, specific latent heat of ice is also given, 336 joule per gram. So it will be 67,200 joule. Amount of heat energy required to convert. Now in how much time? So this amount of heat energy is supplied in 1 minute. 1 minute means 60 seconds. Next, they are asking if this 200 gram of water at 0 degree centigrade will now be converted to 200 gram of water at 20 degree centigrade. So you just calculate the amount of heat energy required by using Q equal to mc delta t. So just substitute the values. Mass equal to 200 gram, C 4.2 joule per gram. Be careful, the mass is given in gram. So C equal to 4.2 joule per gram per Kelvin. Next, change in temperature 20 minus 0, because from 0 degree Celsius to 20 degree centigrade. So it will be 16800 joule. So time taken will be, so this amount of heat energy you have to supply, and this is the amount of heat energy supplied per minute. So you have to find out the time. So 16800 will be divided by 67200 to find out the time, like the unitary method. 67200 amount of heat energy is supplied in 60 seconds. Okay, so 1 joule energy supplied in 60 by this second. So this amount of heat energy will be supplied in, okay. So I have converted this into second. First I got the answer in minute, because 67200 amount of heat energy was supplied in 1 minute. Later you can convert this into second. Next, the amount of heat energy required to convert 1 kg of ice at 0 degree centigrade. Okay, so next question, the amount of heat energy required to convert 1 kg of ice at -10 to water at 100 degree centigrade. So 1 kg of ice at -10, then it should be 1 kg of ice at 0 degree, because -10 is not the melting point. So first you have to bring the temperature to the melting point. Then 1 kg of ice at 0 degree to 1 kg of water at 0 degree. This step will be known as melting or fusion. Then 1 kg water at 0 degree to 1 kg water at 100 degree centigrade. So these are the steps. So first, that is Q1, the amount of heat energy. 1 kg of ice to 1 kg of ice at -10 to 1 kg of water, to 1 kg of ice at 0. So -10 to 0, the temperature of ice will be increased from -10 to 0. So here mass will be taken as 1 kg. Specific heat capacity of ice should be taken, not water, because the state is ice. That is 2100 into the change in temperature. So we got this. Next, Q2, where 1 kg ice at 0 degree centigrade will be changed into 1 kg water at 0 degree centigrade. So here state change will occur keeping the temperature constant at melting point. So here we have to use Q equals to ml, because there will be no change in temperature. So in this question they have asked the specific latent heat of ice, so which is not given in the question paper. So let us take it as y or x, whatever you want. So I have taken it as y. So 1 into y is like y joule. Okay. This is the amount of heat energy required when 1 kg of ice at 0 degree centigrade to 1 kg of water at 10 degree centigrade. Next, Q3. Q3 is MC T2 minus T1. That is 1 kg water at 0 degree centigrade will be converted to 1 kg water at 100 degree centigrade. So there will be rise in temperature from 0 degree to 100 degree. That is, you have to find out by using MC delta T. There C will be specific heat capacity of water, that is 4200. Specific heat capacity of ice will be lesser than specific heat capacity of water. So the total amount of heat energy is like this: 441,000 plus y joule. Now it's given in the question that 777,000 joule is supplied to convert 1 kg ice at -10 to 1 kg water at 100. The total amount of energy supplied is given to you. So you just form and find out the equation to find out the value of y. Clear? Next. Calculate the total amount of heat energy required to convert 100 gram of ice at -10 completely into water at 100 degree centigrade.